Alright. This force here, this is the force when you have two planets or two large objects. So here maybe is the sun, and here maybe is Earth. And you know the Earth.
It's M2.
M1, M2.
Okay.
The Earth is pulled to the sun. Yes? What way does this Earth move? It moves in a circle. Roughly a circle around the sun. So if you want to calculate the force between two planets, you can use this formula. This is the force between two planets.
The G is not
F?
9.
No, it's not. F is the force. What's R? The distance between them. M1 is like the sun. M2 is like the Earth. And G, does anybody know what G means here? It's a constant.
It's 8 point something, I think.
And G here is 6.67 times 10 to the minus 11. That's the G. Easy to remember. Yeah. What's the unit for G? Does anyone know the unit? Kilogram? No. What's the unit?
It is Newton.
Yeah, you might think it's newtons. It's actually not newtons. But good guess.
Newton
meter.
MS over the kilogram.
You're getting very close, Mustafa. Let me check it. You have F equals G, M, and M, and an R squared.
Yeah.
If you bring the R squared up here,
So will be MR.
and then bring the M's down here,
So kilogram squared, that's.
so you'll see it'll be Newton for F, meter squared for the R, and then on the bottom,
Kilogram squared.
kilogram squared.
Kilogram.
So the unit is Newton meter squared over kilogram squared.
Is that the unit?
That's the unit for G.
Okay.
Do you understand how I got this, or will I explain again, Leslie?
Or you maybe need to explain.
I'll explain again. Okay, I'll explain again. So you have F equals G M1 M2 over R squared. I can bring the R squared up here, and I can bring these M's down here. So I have left here just, go ahead, yeah. G equals this. R squared times F over M and M. Can somebody tell me a formula for F? What does F equal? MA. So if you want, you can also rewrite that in, but we'll just leave it like this. What's the unit for R? What's the unit for R? What is it? No, radius. What's the unit? Radius is distance. What's the unit for this? M. What's the unit for force?
N.
What's the unit for mass?
kg.
And for mass? Kg.
Yeah.
So here is kg squared.
Kg squared. Oh, I understand.
You got it?
I got it.
Good job. Okay. And yeah, you can simplify it more because Newton you can make is MA. And you can say M is kg, and you can cancel the kg here. But if you want to just write this, that's fine. But do you want to simplify? Yes, we'll simplify it, okay? So we can simplify this a bit more. Remember that F equals MA. What's F? Newtons. What's M? Kg. And what's A? Meters per second squared. So I can put that in here. And I get M squared kg M over S squared all over kg squared. So what I did there was replace this N with kg M over S squared.
So we can't leave it with N?
Oh, you can. What I was saying, I think you just stepped out, was you can. Now let's simplify. This cancels this. Yes?
Yeah.
What else can I say?
And the square?
I can put this down here. So the m multiplies this to make
1m.
m squared by m
3.
3. So it looks like I get m cubed over s squared kilogram. So meter cubed per second squared kilogram. It's another way to write it,
Okay.
if you want. Yes, Ted?
Yes.
Are you thinking of something else too?
No. Same.
Same?
Yeah.
Okay. Which way is easier to remember?
I think the first one.
Yeah, first one's fine, okay? First
Yeah.
one is fine. Okay. Shall we look at some... Yeah.
G is this is the SI unit for the G.
SI unit G, yeah.
G is always remain a constant. It's like a G in
Yeah, for the
graph.
universe.
It's like
It's-
same.
Same everywhere.
But they will test us on this SI.
I think this is in the exam book. There it is, there.
6.67.
And they give you the small g as well. And look, you have the electronic mass. You know, you have all your values here. Okay?
Yeah.
All right.
But there's no the formula, right?
You should remember the formulas, yeah.
Memorize it, not to remember.
Memorize them, yeah. Okay. Let's have a look at some examples now. Can I go to a new page here?
Yeah.
All right.
So you will give us the paper later?
You can get it on Moodle, but I can print it out for you.
Sure. If you will.
Next one, Newton's law of gravity. So this is called Newton's law of gravity,
Yeah.
or gravitational attraction. Okay, let's have a look at some
The
questions.
It's not the G that is 9.81.
Yeah, we can actually have a look at something with that now. Okay. I know, your life is so difficult. Okay. I just actually want these numbers for the moment. Let me show you an example here. Okay. Here's Earth, and here's Moon, and all the information. Okay.
The
So
first one or the second one?
let's draw an example.
Okay.
Here you are on top of the Earth, and here's the Moon. You feel two forces. What are your two forces?
The moon and the sun.
Let's just do Earth and Moon for the moment.
Okay,
But you're
Earth.
right, there's the Sun as well. So we will just do Earth and Moon for the moment. So you feel the force
Of Earth
to the Earth
and to the sun.
and
Moon.
to the Moon. Okay?
Yeah.
Let's calculate each of these as an example of using the formula. So let's say our person has mass of 100 kg.
Okay, so 3 m's.
Yeah, roughly. So let's just do the Earth one. So force equals G times mass of the Earth,
That's 6. Okay, 24.
6 times 10 to the 24.
Over.
Let me
What's
make,
the distance between them?
yeah, we'll have to calculate that. Well, we'll have to look at that. I'll draw this a bit better. There, okay. Let's just do him on the Earth now. So what's the distance here? If he's on the Earth, what's the distance? Yeah, it'll be this one here. Radius of the Earth. So let's calculate. F equals G, what's G?
That's 6.7.
6.67.
No, 6.7 without 6.7.
Oh, he tells you to use...
The first one.
Okay.
Meters? Is it just meters then?
What? This?
Yeah.
No, there's the unit. Newton meter square per kilogram square.
The radius of the
Radius of Earth is in meters. Yeah, of course, because you measure distance in meters.
I mean, yeah. Is it real?
Oh, these are real numbers.
Yeah.
Yeah. 6.7 times 10 to the minus 11. It's actually 6.67, but we'll leave it like this. That's G. What's the mass of the Earth?
6.
6 times 10 to the 24. And then what's the mass of our person?
100.
10 squared, 100, all over 6.4 times 10 to the 6 squared. And you'll definitely need, you're just going to let me do it, huh? All right.
Like,
Oh, sure, why not? Okay. 6.7 times 10 to the power of minus 11 times 6 times 10 to the power of 24 times 10 squared all over 6.4 times 10 to the power of 6. That equals 981 newtons. Everybody look please, Ted. I used this formula, and what did I get as the force? 981 newtons.
Yeah.
Now I have another formula. Think for a moment. This force is the force he feels when he's on the surface of the earth being pulled to the earth, right?
Yeah.
What is the name of this?
what name is what?
The force that pulls you to the earth. Gravity.
Gravity.
So what do you call this force? It begins with W? The force that begins with W.
Work?
No. Weight. And what's the formula for weight?
F.
Mg. And what's the M?
That is
100.
Yeah.
And what's the G?
9.81.
9.81. 100 multiplied by 9.81?
It's 98 one. Same, yeah.
The same. The same. It should be the same, right? Why? I'm showing you it's the same. But you can only use this formula when? On the surface of the earth. If I send my man into space,
So it will be more, less weight.
less, yeah. So what I want everybody to do is, I send my man into space, and now the distance is twice as big, double the distance. I want everybody now to calculate the force.
For the moon or the same earth?
Let's just do the earth for the moment.
Or the double what? Double.
Double the radius. You're just going to change what I typed in.
245.
Yes.
245.
No, I do think it's 245. Do you want to just double check? Did you put the... Wait, hang on. Maybe he typed it in wrong.
No. Just multiply 2.
Multiply what by 2?
That's 6.4.
Yeah, that's right. But you might have put in the wrong place.
5 square, so did you divide by 4?
Yeah, that's what I'm checking now.
Divided by 4.
You got it wrong.
So what? Divided by
It's square.
It should be... Oh, hang on. What did you get now, Hussein? I think he's right. Albert, you want to just double check your calculation there? Double the distance. No, I think...
It's not what, yeah?
No, that doesn't matter. I think you got it right. I'm sorry, Hussein. It looks like he's right.
Something else.
What did you get?
1.91.
Yeah, which is the same as what Albert's getting, yes? 1.962.
Yeah. 1.6.
Not just multiplied by 2. That
Yeah. If you look at his calculator later, the only thing I changed was I put a 2 here. So that should just now be 12.8.
Oh well, yeah.
So if you just change that to 12.8 and see if you get the answer.
It's just the same now. I will do it like that.
no, but you didn't multiply by 2. No, not like that. Same.
So the answer is
Just wait here.
490.
No. Yeah. Okay.
Yeah, the answer is 245 newtons.
Okay.
So,
No, see, there's a lot of questions together. That's all.
490.
So do it from the beginning.
I think you have to use more brackets in your calculator.
11 multiplied, that is
August?
also 29
What have you got there?
100. It's 2 multiplied 6.4.
Is it a calculator?
6.
No. Did you calculate this?
It's how much you got, Mr. Steven?
245.
You got more than 245. You get 245.
Yeah, point. Yeah, just
No,
to
245, 10 power 7.
sounds like you're having trouble inputting on your calculator.
I'm bad with technology.
Okay,
Okay. I got the.
So if I just double the distance instead of instead of 6.4, what will the distance be? 12.8. So that changes the force to this. And if you keep increasing the distance, what happens to the force? It gets smaller. And what happens now when I make R go to infinity? What will the force be? 0. Yes, wait, Leslie first, then you, Albert.
I'm still confused. Why R, one y r is infinity, f equals 0.
Because you have F equals G M M over R squared.
Yeah.
If R is infinity, you have this.
Okay.
1 over infinity is 0.
Okay.
So this becomes 0 when you go off into the distance.
Okay.
What does infinity really mean?
Well, you can't, yeah, exactly. It doesn't mean anything here, really.
Because
The only point I'm making is saying that if you go far enough away, you don't really have any force from the Earth anymore.
It's
It's-
not a constant speed account.
It's more like, look here. If here's our Earth, and I'm here, and then I move here, what happens to my force? Smaller. And if I move far enough, my force will become practically 0.
Oh, it's like 1 over 1, 1 over 2, 1 over 2, and it slowly becomes.
It becomes smaller, yeah.
Can I ask you something?
Yes.
What if we get closer to a unit that has bigger mass, so the force will grow the more we get far?
Can
For
it get?
example, there's sun, there's earth. Earth.
Yeah, okay, good. Alright, let's have a look at another one here. So, like if you have here's the sun, and here's the earth. And if I move this way,
Yes.
the force from the earth gets smaller, but the force from the sun gets bigger.
Yeah.
So if I'm here,
So further we are from the earth,
the sun, yeah,
bigger is the force, yeah?
at some place in the middle, something, or maybe not in the middle, maybe more like here. What happens at this special place here?
Balance.
They'll be balanced, and you just float. You won't move anyway.
So for you computed the man for the first time when he's on the surface on the earth, just nice. And
Yes.
second time you computed twice, so he's outside the earth.
He's
but
on
he
space, yeah.
Use the mass of the earth, so that means that's the force between the earth and the man.
Yes, that's right. Yeah.
So if we want to calculate that further, we have to calculate the.
Yeah. So like this one here. Let's find this special place. Yeah.
Sorry. But I think you won't stay in the middle because the force from the sun will give an acceleration.
No. This is important. This is very important now. Look here. I'll give you an example. Do you all know what a satellite is? A spaceship. You know, spaceship.
Mm-hmm.
Here's Earth. Here's Moon. Look, August. If I fire a rocket here, Earth pulls me this way, Moon pulls me this way. Which is greater? Earth.
Because nearly to
But at some point,
it will
here,
be in the middle.
the Moon will be bigger and the Earth will be smaller because I'm so close to the Moon. So there must be some point in the middle here when the force from the Earth equals the force from the Moon. And this is the special place. If I pass this, what happens?
It will go to the moon.
It'll go, I'll fall to the Moon. But if I stop before this place, what happens?
To the earth.
I fall back to Earth. And if I stay exactly here,
You will be in the center.
I will not fall to the Earth or to the Moon.
So that's how the satellite actually stays there.
No, that's something else, which we can do now in a minute. Let's do the satellite one, okay?
Satellite?
Yeah, satellite. You know,
Time's over.
like Sputnik. Do you know Sputnik?
Waiting for TV? Satellite TV?
No. For satellite TV, yeah. Do you all know Sputnik?
Yeah.
What's Sputnik?
That's for the TV that over.
Oh, no. What's Sputnik? Do you know Sputnik?
Sputnik.
Sputnik, it's Russian.
Yeah.
Sputnik.
Do you know Sputnik?
Can you give me a reminder?
No, I never told you this before. This is new information. Has anybody heard of Sputnik before?
That's the moon.
Sputnik.
Electronic moon that a
No.
Oh,
It's a noun or thing.
it's a thing.
It's a thing.
What thing?
In 1969.
No, before that. You're thinking of Apollo 11.
Before that.
Before that.
Is it the one with Yuri?
Before that.
Before
Before that.
Landing.
Alright, so the first satellite.
The very first satellite was put into space. Who did this? Russia.
Russia.
And what was the name of the satellite? Sputnik.
Sputnik.
Okay.
Yeah.
Did you know this,
How are you?
August?
Yeah, I know this in Chinese.
What's Sputnik in Chinese?
You can tell me.
探求者号.
Wait, that's Sputnik in Chinese.
Explorer.
No, not Explorer. That's something else. The very first satellite in space. What's that called?
Yuri Gagarin.
No, before that.
No, that's
That's the
human.
thing.
That's the first man.
Okay.
You mean that the things around the world?
Yes,
the
the
air,
first. Yes. It's Sputnik.
like in
But
a-
what's Sputnik in
like
Chinese? It must be
electricity,
Sputnik
big
too.
electricity
You can
and-
tell me again.
Just open the image and then Google. What you are doing, asking everybody.
No, but I thought people knew this knowledge. What's it? Sputnik, maybe something like this.
Just open the image.
Sputnik 1. Yeah, there's the picture.
So this is the first.
This.
So this is the first ever satellite.
It's like
Yeah.
spider.
Can you open the image and
So-
go?
That's the satellite.
Have you seen this before?
No.
Can you
No.
Can you
No.
go back to the Google?
I'm leaving this here.
In Chinese history book, they only tell us Yuri Gagarin.
That's all.
Yeah, that's all.
Okay. This here. Is this? Am I telling you something new? Yes.
Can you go back?
Why? No.
Just a
leave
minute.
this.
I know. Just go back. No.
Yes.
Yeah. Again. Yeah, put image. No, there's image. Right there. Yeah.
But it's going to be the same image. Why am I doing this?
Not different. Yeah, this one.
So what does it actually do for the first satellite?
This is the first satellite in space.
Radios.
No, for nothing.
No.
Just the first satellite in space. I think it just took some pictures and landed. That's all.
Oh.
I don't even know if it took pictures. What is the name of this in Chinese, August? Does it even have a name? Okay.
I think it's again the same thing.
Well, what's it in Arabic? It should be the same because it's the
Sputnik,
name.
Sputnik,
Yeah, Sputnik is Sputnik.
No, in Arabic I think moon. What can I? No, it's supposed to be.
We've never taught that in Chinese.
That's interesting. Okay. Well, now you know it.
Yeah,
The
no.
first machine
Uh-huh.
in space is Sputnik number 1.
Okay.
It looks like this. It's like a ball,
Like a spider.
like a spider, yeah.
不多吸引。
Is it in the dictionary?
伴侣号，那应该叫伴侣号。
That really?
Can you see your iPhone? It's open next to me.
Do you know this word,
Yeah, but-
Leslie?
No.
If you can just
Maybe.
Say it again. August, can you tell Leslie it?
Chinese.
But-
See the
but-
Chinese name.
Just
I'm
write
sure
the
that
name.
taught in middle
Sputnik
school or
in
high
Chinese.
school.
Steven.
我知道，我见过一张图像。
Yes?
Yeah, so
Write the name in Chinese.
No.
Sputnik.
No need
No.
of writing. Just choose a Chinese section in Wikipedia. If you go to Wikipedia.
I can choose Chinese and
No, just go to Wikipedia tab.
I'm going back to Wikipedia.
Oh, it's left. Oh, it's circle motion. Yeah, that one. If there's a Chinese option, go down, please.
Where,
Yeah.
Oh, I see.
If there's a Chinese option.
Just write in Arabic.
No, wait. Where's Chinese?
Well,
Is this it?
Yeah.
No, it's
No,
Korean.
that's Korean.
It's Korean. This is
No,
Japanese.
Japanese.
What's the difference? All the same.
Yeah.
Here.
This
The
one?
last-
Yes.
Yeah.
The last one.
The last one.
so. What the hell is this now?
1957.
At least I'm sure we've never taught them.
Okay.
Alright, how do you read this one? Alright,
Can I see in Arabic?
Well, you can see later. I need to do this
Go
example.
back. Just a minute. Go above.
This one?
No. Go. Not here. Yeah.
This one?
No.
I'll do it.
No, again. Okay. No.
This
More.
one?
Yeah. The first one. Yeah. No. Yeah. Same name. I think. Yeah. Same name.
So you say it as, pronounce it how?
Yeah. Okay.
How do
I
you
know.
pronounce this?
I don't know.
You don't know Arabic. I know.
How do you pronounce this?
It's called. You know this the blue one.
No, just read this for me. Read it. How do you pronounce it?
Qamar Sanai. You don't know how is it?
All right, okay.
I will write it in
Let's look
English.
Turkish then.
No, I'm just surprised because it's a name, and I thought the name shouldn't change in other languages. You know, like Sputnik should be Sputnik. Okay. Anyways, you haven't learned this in school before, no?
Yeah, haven't
I
learned
think
that.
it's like this. If you can read it.
Pass. All right, let's have a look at an example. So,
Turkish.
it should just be Sputnik, really. It should be. Okay, look here. So, let's just do one example and we'll finish, okay? So here's our Earth, and let's say here is our satellite, our Sputnik, whatever.
Whatever. Yeah.
And what do you think happens if the time is 1 day to travel around the Earth? What do you think happens?
Take a lot of time. A lot of years.
Like picture here, here's me here, okay? And suppose this takes 1 day. If I look up, what happens?
It's full.
It follows you. If this takes 1 day, and you look up and you see it there, it'll always be there. Now, suppose this takes half a day, what happens?
You go half a day.
This is going faster or slower than you?
No.
Faster.
Slower.
Faster.
Yeah.
So what looks like it's happening,
Yeah.
going fast, okay?
Yeah.
I think Sputnik #1, it only took maybe a few minutes to go around. So if you look up in the sky at Sputnik #1, you see it goes very fast.
But it's not
Yeah.
possible for us to.
No, at night time you can see like a little white dot,
Yeah, meteor.
like a meteor, and you see it moving across the sky. Okay, let's calculate this here. So 1 day, you need your calculator. How many seconds in 1 day?
So there's 24 hours.
60 seconds,
Multiply 24.
60 minutes, multiply 24.
So it would be 68,400.
Yes? 60?
86. Sorry. 86,000.
86,400?
Yes.
Okay, 86,400 seconds. And how many turns does it do in this time?
1 day. Once.
One. So what's that? What angle?
One
So
multiply-
2 pi in 86400 seconds. Okay? So 2 pi divided by this, Mustafa. Can you calculate that?
2 by 86400. Already? Yeah?
Yeah, it doesn't matter.
Will be 7.27. 10 power minus 6.
Radians per second. Very big or very small?
Small.
Small, but it should be small because the angle changes very slowly. Okay? Now, this is traveling in a circle, true?
Yeah.
So what's the formula for force because it's a circle? M
G
omega squared or. Do you know M? Well, yeah, it's for the
Yeah.
satellite. Do you know omega?
Yeah.
Yeah, and do you know or? Yeah, you could know or. But also, what other type of force is it?
MV squared.
No, no, no. It's circular, but it's also a gravity force.
MG.
No. GMM over R squared.
Okay.
This because it's traveling in a circle. This one because it's being
Space.
pulled. Yeah. So what can you do with the F's? You can cancel them.
Mhm.
So you can make this formula now.
And cancel one of the
And
M's.
cancel one of the M's, yeah.
and one of the R.
M omega squared or equals GMM over R squared.
So R will go that way.
Yeah, so hang on. We'll cancel the small m. Okay. We know omega.
And the R with the square.
We know omega.
Yeah.
Just wait a second. Wait. We know omega. We know G.
Mhm.
This M, what's this big M?
That's for the air.
Earth. We know this.
Mhm.
So what do we not know?
R.
R. So I'll just say R cubed equals GM over
W squared.
omega
Squared.
squared. So I want then cube root. Okay? So this here is the exact place you need to put your satellite so that it takes 1 day to travel around the Earth.
Okay.
Like, well, Sputnik was faster than this. Why do you think you would want your satellite to not move in the sky?
What?
Why do you think you would want your satellite to not move in the sky?
Because a lot high, the big distance between you and them.
No?
Not possible.
No, it's possible.
But it's take a lot of time to move.
No,
So 1 day for them.
No,
is
no,
one
no,
good
no,
day
no,
to
You're not
move.
moving the sky.
No.
Go with the, so you should go with the same angle.
yeah, look, come on. Listen to me carefully.
Yeah.
If the satellite takes 1 day, then it looks like it's not moving. True?
Yeah.
Yeah.
Why would you want this? Why would this be a good thing? Any ideas?
So that you can check it.
No. Any ideas?
Because the angle will also is the same.
Yeah, but why? Why is this good?
It's a good thing.
Yeah, it's a good thing. Why is it a good thing?
You don't think about it.
It depends on why did you send the...
Yes, very good. Why do you normally send a satellite into space? For what purpose?
To take a picture from a high place.
Not so common. Yeah.
To see what's going on Earth.
Yeah. That's
Come on, guys. Why would you put a satellite into
It's
space?
fine.
No, not something something boring, something normal.
To watch Earth.
To calculate the.
Oh, guys, come on. Why would you put a satellite in space? Why?
To know how is the Earth is moving.
No,
and like
no.
Transfer the signal.
Yeah.
For what?
Signal.
Signal, like television.
Yeah.
So if you have your television,
Yeah.
you want the satellite to stay in the same spot, because if it moves, what do you have to do every day?
Great.
To
You
move.
have to change where your TV points,
Yeah.
right?
Yeah.
Like if the satellite is moving, every day you'll have to change your
every
TV,
time, you mean.
every time, right? But if the satellite stays in the same spot,
So you don't have to
you
change.
just point your TV to it
Yeah.
and you're finished,
But the satellite is only 1 point.
Yeah.
right? I have to give you some word. So this here is for the satellite to stay in the same spot in the sky. You understand?
Yeah.
The name of this,
Which one?
of this satellite that takes 1 day?
Spotlight.
No, 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 no.
Static.
Stationary or parking orbit.
Okay.
This means it is
The
not. It's
nice sat orbit outside.
huh?
No, okay. You don't have this thing.
Stationary or park in orbit. Did you write this word down, Ted? And August?
Stationary.
Yeah,
Stationary and parking.
parking orbit.
Parking orbit.
It means it takes 1 day
Yeah.
to do 1 revolution.
What? Parking?
Stationary or parking orbit.
Parking.
Yes.
But the satellite is only one point and the other point doesn't exist.
Huh?
If the satellite is
Wait.
if the satellite is on one point and the other point, we wouldn't receive it.
Yeah.
Opposite point.
Look, just to finish, okay? Here's you, TV, Earth, satellite. If this takes 1 day, it looks like it's staying here. It doesn't move. So the signal, you just point it here, and that's it. Now, if this takes half a day, what happens? It looks like it's moving. So this needs to move. It makes your life more difficult.
Yeah, so they need to equals.
Yeah, they need to
union to be union.
So in
Yeah,
the past,
no
they were,
movement.
every time they were moving the
No, I think actually, I don't know when the first satellite was for television, but the first one, it would have to be stationary. And another reason, you know, in your car, you have a little map,
Yeah.
and it tells you where you are.
Navigation.
Yeah. This,
GPS, yes.
this here doesn't move. This here doesn't move. So your satellite goes, and it calculates where you are. If this moves, you cannot calculate it. So this is fixed reference point.
So for GPS there is 2 satellite.
Huh?
For
For
GPS,
GPS, you need at least 2, but in fact, I think it's as many as 7. So you have 7 satellites, 1, 2, 3, 4, 5, 6, 7, and your car is here, and it,
How many satellites in the world now?
oh,
Out of the space.
you're probably talking something like maybe 60 or 70,
Really?
or maybe something like this, yeah. It's quite large. I think, now I might be wrong, but I think it's about 1 satellite per year.
Oh, they are changing every day?
Every year there's a new satellite, I think. Or maybe once per 2 years, I don't know. In fact, I think China is going to send a satellite into space recently.
Yeah.
Is this true?
Yes.
Yeah.
They will or they have?
They will.
They have.
They have?
have?
神州几号
10.
Okay, that's good.
Is this the name of the satellite?
Yeah, Shenzhou 10th.
Shinzo Tent.
10th.
10.
Yeah.
Okay.
Yeah, Shenzhou 10th.
Is the first Chinese satellite?
No, the 10th.
Really?
Yeah.
All the previous
Yeah,
ones?
Shenzhou 1st, Shenzhou 1, Shenzhou 2, Shenzhou.
Is this true?
Yeah.
So China has 10 satellites in space.
Yes.
Yeah, and maybe 8 or 9. Not 10 yet.
Maybe one broke?
Yeah.
Made in China.
神州 is
Yeah, every time they will cite 2 or 3 the same thing. In case
In
one
case
will-
one breaks.
Yeah.
Yes, I know.
So
yeah.
that will replace another thing.
I understand.
Yeah.